So Qubole has a job scheduler, and it's a built-in job scheduler. The job scheduler will allow me to do things like schedule a number of different command types. The one we're interested in is the Spark notebook. So you can see I can come down here, and let me pick my Spark cluster here, and you'll see, what was it called, e-commerce insights notebook. That's the notebook we were using. If I had this notebook parameterized, I could pass arguments to it on the fly. So if I'm running this on a daily or an hourly or even a cron, I might want to pass in the current time of the execution of the notebook, so that we can pass that into your code within the notebook paragraphs. The Qubole note scheduler. So the Qubole scheduler is managed by the Qubole, within the Qubole tier. The great thing about this is that if my cluster is down, what I mean by down is there are no running, instances associated to that cluster, Qubole will auto-launch that cluster, process the job, run it, and then if the cluster is idle after that, it'll terminate it. So really great feature for cost savings. The other thing is, obviously, I want to productionalize this. I might want to send out notifications if something fails. I have the ability to integrate this with email or PagerDuty. There's a number of things that we would support there in terms of endpoints. Really cool feature for being able to get alerted if your job fails, say in the middle of the night. So again, that was a really quick and simple way for me to schedule jobs. If I'm doing something a little bit more advanced, say as a data engineer building pipelines where I'm ingesting data from multiple sources, this particular scheduler might be a little bit too simple, or I might want to do something, using Airflow. Now, I haven't gotten to the clusters part yet, but one thing I do want to show you is Qubole supports the ability to create an Airflow cluster. And once you've got that running, you have the ability to access the Airflow web server UI, as I've got here. And the data set that we've been playing with so far is actually built using an Airflow DAG. So if you're familiar with Airflow, great. If not, Airflow really briefly is an open source project that allows data engineers to orchestrate, or data scientists as well, to orchestrate workflows. And the way that's built is using, what's called a DAG, directed acyclic graph. And really, this is Python code where I would do things like define tasks. As you can see here, I've got a Qubole operator, which is creating the schema of my tables. Then I've got another Qubole operator where I'm importing data, and so on and so forth. And then I basically define the flow of what these all look like, and then you get a nice visual of what that looks like when you click on the graph view, and you can kind of see what's happening here. So what's happening here is that Qubole is actually importing these things from MySQL database. So I'm going to click on this Go to QDS button here. That actually should take me to the actual data import instance. As you can see, this is a data import instance. It's pulling in data from a MySQL database. I'll actually show you what that looks like, and populating a Hive table. And what that really is Qubole allows you to create connectors. So I'm going to go to the Explore page, check out my data connections. I've got some shared ones here. So that e-commerce data set that we're playing around with, the data originates from a MySQL database, and there's a number of tables out there, just as an example to show that we can pull data in from MySQL. You can see here, here's my MySQL instance on AWS. It's an RDS, and I've got the order items table. I've got the products table. I can kind of browse this stuff once I get a connection. So giving you a feel for how, as a data engineer, Qubole makes the ability to stitch these things together really easy, productionalize them. There's a number of things you can do in terms of troubleshooting. where I have access to, the logs all in the UI. I can do all this programmatically as well. I also have access to back-end information. So in this case, it was a Hive query, so I can access the Tez UI. And you'll see the ability to drill into this stuff. Again, really powerful for that persona, keeping things really simple. The great thing is all of the back-end stuff, like if you're talking Spark and the Spark UI or Yarn, all of the back-end histories are made available offline. That's all stored back out into the customer's S3, and you can fetch that stuff all offline. All right. We've talked about 3 different personas so far. We've talked about the analyst, data scientist, data engineer. What I want to do now is touch on the cluster and what that is, right? So, I gave you a glimpse of that when we looked at the Airflow clusters, but if I go to the clusters page, if I'm an admin or, even a data engineer, or maybe there's a platform team that owns sort of the operational aspect of this stuff, what clusters are in Qubole, they're ephemeral, right? They can be in multiple states. They can be down. As you can see, I've got a number of inactive clusters. There are no physical instances running. And by the way, when we're talking about instances running, that stuff's running in our customers' VPCs on AWS or in GCP, in their tenants on Azure, right? There's a control plane and there's a data plane. The data plane runs within our customer's environment. So this is actually orchestrating EC2 instances within your cluster. Nope, looks like one of the clusters is actually going down because it was idle, right? Somebody was using another cluster in here when it was idle. But just to show you how easy it is to create a cluster, click that. Let's say we want to pick Spark. I give it a name. Right, I've got the versions. A lot of this stuff will be defaulted to what works best. And in Spark's case, we've got, the R instance types picked. The thing I really wanted to highlight in here is this minimum worker nodes, maximum worker nodes. This is one of the key value pillars for Qubole, and that is our ability to help manage our customers' cloud spend, right? We have a best-in-class total cost of ownership model when it comes to running big data or data lakes in your cloud. And this right here is one of the reasons why. There are 3 key reasons, right? One is the ability to auto launch the cluster when it's time to be used, whether that's coming in via Tableau or the API or the UI. You'll see that the Qubole instances will be fired up when somebody submits a job against the clusters. The second reason is this, and I'll get to the third in a moment. This is the workload-aware auto-scaling boundaries, if you will. And what this allows you to do is set boundaries. So if you've got cost that you want to kind of limit on or SLAs that you need to meet, this is how you would do it. Qubole will take care of automatically spinning up instances based on the workload. That intelligence, there's a ton of intelligence put in there, both on being able to upscale right at the right time with the exact number of nodes that you need, as well as downscale aggressively when the cluster instances aren't being used. Like I said, we've got a ton of IP around there. There are numerous white papers on this stuff, but the idea of being able to pack containers and offload, shuffle data and things like that really make this a valuable feature. In fact, this is a shared Qubole account, and there's a cluster here that our team uses for some BI purposes. I picked this one because it gives me a nice view. One of the things that you'll see here is there's a chart that gives you node versus time, and this is in the product. What you're looking at here are, for this particular cluster, over time, how many nodes it was using, again, graphed over time. Few things to notice here. First of all, notice that there are these spikes. These spikes represent our ability to scale up the cluster very rapidly and then scale down the cluster when it becomes idle very rapidly as well. All of the white space you're seeing there, that's all cost savings, right? Because otherwise you would have had a cluster that had, let's say 20 nodes running all the time. Now, the other thing to notice is I mentioned there were 3 things that drive the cost savings, and I talked about 2 of them, the cluster lifecycle management, that's our ability to auto-start and auto-terminate clusters, the workload aware autoscaling, which is the up and down that you're seeing here. The third thing is our ability, Qubole's ability to allow our customers to leverage spot instances. And the spot instances are represented by this light blue teal color. Again, that's spot in AWS, but we do this on all of the clouds. So on GCP, these are the preemptible instances on GCP. Again, those are volatile instances for folks that might not be familiar with that. The clouds provide a way for you to leverage volatile instances at a discounted price. These are excess capacity usually. The trade-off is that they can take those away unannounced almost, and therefore many people tend to shy away from that because of the instability. What Qubole has done is built in intelligence into the platform, which allows our customers to use spot instances at massive scale. We've had customers use 90, 95% spot, in some cases 100% spot clusters. So over the last year, Qubole's helped our customers save $230 million, right? And that's compared to using an alternate solution, something like EMR or otherwise. If you look at since Qubole's inception, since 2011, we've been able to help our customers save over $500 million in cloud spend. That's pretty amazing. And if I look at that, like on a single instance, we've seen customers, come over from a competitor or an alternative solution, save anywhere from 50 to 60% on their cloud spend. And this is how it's done, as you can see here. So I wanted to end with one more quick thing. As you use Qubole and the Open Data Lake platform, there's a notion of clusters. These clusters are generally scaling up and down. We have the ability to support multiple workloads, multi-tenant on the same cluster, so you can drive for really good efficiency when multiple users are allowed to share the same cluster, and Qubole takes care of the scaling up and down. With that, there are trade-offs, right? If everybody's logging in, you got different types of personas. There are trade-offs. And you need governance, right? So Qubole provides the ability to, have fine-grained access control, role-based access control to different functions and features, and that's all managed through here. As you can see, I can set up groups and roles. I might have data scientist users. I might have engineer users. I can give them access to different functions and features within the product. I can do this at the data level as well. I have column level masking capabilities, row level filtering capabilities. All of that stuff is built into the platform. The other aspect of governance is financial governance. The other thing that Qubole does is we provide data back to our customers, and we give them dashboards on being able to do things like attribute cost, right? There's a number of things that we provide out of the financial governance cost explorer piece. One of those is the ability to say, hey, what portion of the cost came from which users? And so in this example here, I've got a dashboard available. I can run that query within the dashboard. I can actually show you that. Oh, sorry, I just closed the book here. There we go. What we're looking at here is user attribution against a particular cluster. So I'm going to change that to the cluster that we were looking at earlier with the up and down spikes to really see which users are using this cluster the most and what percentage of cost we can attribute down to the user level, down to the command level, down to the job level. As you can see here, this is one of our team members who happens to be the head of our BI team and is obviously the one that's using this cluster the most. And then the top three are all in the BI team, and there's a number of folks that also use this data lake instance. Again, this is part of the Qubole Cost Explorer product. What we're doing here is we're shipping data into our customer's cloud object store and then providing them with a set of out-of-the-box dashboards or notebooks, which allow them to run and power use cases like cost chargebacks or return on investment analysis. There are notebooks that are geared towards total TCO, so I can get a view of how well am I doing? Am I using spot instances? What percentage am I using spot instances? What does my auto scaling look like? That data is shipped to their cloud object store. So not only do they have the out-of-the-box notebooks that they can use to analyze that, they can slice and dice that, build alerts on top of it, whatever they wanted to do on top of that. So that said, as you can see, we took a long tour through Qubole, looked at a number of different features. There are several things that I've left off here. We'll probably have deep dive demos on various aspects. I wanted to thank you for your time and also let you know that if you're interested in taking Qubole for a test drive, we actually have a test drive available. It gives you access to Qubole for 14 days. It comes with some brilliant built-in examples, and that sits on top of an example data set that's available to you. So you have everything you need to start playing around with it. You can run through the use cases that I showed you here today. And then there are other things that are built in as well that you'll be able to play with. So take a look, and thank you again.